So what we're going to do now is we will first of all review for what we did last time. So I'm creating my new class as Review Chapter 3, Public Static Void Main, Finish. Last week we learned about creating methods, or what you called modules, right? And then we were calling them from the main. So we learned about the modularization approach in Java. Then we took that approach further, and then we started to pass parameters, value returning, and then we learned about the difference between the value returning, non-value returning, static, non-static. We created classes, properties, getters, setters, and instances. All of that stuff we will try to recap and connect it to chapter 4. So that's why while I'm reviewing chapter 3, I will also be connecting to chapter number 4. So I'll tell you when I'm doing that. So anyway, to get started, I want to create a static method. And static method maintains a single copy in the memory, and that copy is for everybody. Doesn't run many copies for each instance. So this method will be used to display some kind of a calculation output. Okay, so we will be able to that way recap the operators we learned in chapter 2 and data types. So public static void, we are calculating force, which is mass times acceleration. So we simply multiply the two, and then we display the output that this is the force. So this is modeled after the main. It's a module. It's callable. Any number of times you want to call, you can just simply make a call and pass the required parameters. And those parameters are getting multiplied to calculate the value for force, and then we are displaying the value for force. So here we are calling compute, and we are passing a couple of values. Oops. If you want to call it again, we can call it again. So once you create a module, you can just call it any number of times. And since we are calling it twice, we expect to see force calculated twice, and that's what we see down in the output window. Okay. Now, the next thing would be that instead of hard coding these, I would like to accept an input from user. And we learned last week that you can create a value returning function because I have 4 values. Instead of creating 8 lines of input output, because I need a message line and I need an input line. I need 2 sets of lines for each of the values, so I have 4 of them. So instead of doing that, I can simply create a value returning function which will accept a value for me and will return the value to me. All I need to do is call it. So we're going to be creating a value returning function here. Public static double value. We'll use a scanner object to get our input. It's the same stuff we learned from chapter 1, the first week of class. Now, let me give it a parameter message so I can customize whatever kind of an input I want to accept, because sometimes I'll be accepting mass value and sometimes I'll be accepting acceleration value. So that's why I would like to go with that. I'll accept the So whenever you call this function, you have to pass one parameter of type string. It will use it to display the message, will accept the value from user, and will send the user back the value. So to make that happen in the main method, I will declare mass will call the value with an appropriate message. So I'm replacing line number 8 with variables, and I'm leaving line number 9 with the values. So now when I run this program, it will ask me to enter mass, and then will ask me to enter acceleration, and will display the force is this much when the values are accepted from user, and force is this much when the values are hard-coded. Now it is also possible for me to directly call the value without taking help from the variables. So what I can do is I can directly put the call to value within my parameters, just like this. So what will happen is when the compute is called, it will first call value, will pass enter mass, and then it will call value and ask for enter acceleration. When both values return to their respective positions, then compute will be called. So you do not always need variables if you're simply making a call. So the first one may act differently than the second one. Behind the scene, however, you will not going to see much difference in front. See, they both give you this exact same output. Now, let me create another method called compute. But this time I'll create a compute with one parameter. In that case, it will going to be called overloaded. Overloaded is a concept where two methods have exact same name, but difference in parameter. So simply copy paste this method and down to a single parameter, and it's going to be a different formula. So when I'm calling compute now, I will going to pass a single value. And when I pass a single value, it will call the compute from line number 18. It doesn't ask you for any input for the weight, because the weight, we are hard coding. But you can also call it like this, and this will call the compute with one parameter. So the whole idea of multiple methods with same name, different parameters, is what's called overloading. And that's where I'm transitioning from chapter 3 to chapter 4, because overloading is a concept explained in chapter number 4. So it intelligently makes the decision based on the number of parameters, which version of compute to call. That when we call compute with two parameters, it calls the one with two parameters. And when we make a call to compute with one parameter, which is both of these cases, it intelligently picks the version of compute that takes one parameter. And this is called what? Overloading. Overloading. Now, how would you call it from the main? Now you pass three values. So now when you pass 3 values, it will automatically call the compute that takes 3 values and multiplies them and displays the output. So each call matches to the version of compute that matches the number of parameters. Call maps itself to the number of parameters on the receiving end. So now instead of 3 parameters, I would like you to make it 4 parameters, where the 4th parameter will be of type string called message. So add a 4th parameter to the list of type string, and the name of the parameter will be message, MSG. As soon as you do that, line 12 will error out because there will be mismatch. We will fix that after we are done fixing line 27 and line 29. So we add a 4th parameter message, and we will replace this double quotes X with that message. Something very similar to what we did down below in the value returning function. It's the same idea. So since the concept is so generalized, where you take 3 numbers and multiply them, that it could get any meaning. So I would like the main to dictate the meaning of the call. So that's why we are making this happen, the 4th parameter, okay? So now the main will pass the message that this time it is calculating volume. Next call may be that it's the value of X. And as you can see, my last 2 outputs, calling the same compute, but once displaying volume, the second time displaying value of X. Everybody got this? What I would like you to do is, in the second version of compute, move the 9.8 in a constant called gravity, and then use that. So declare a constant to store 9.8. Name of constant will be gravity. Then use this constant in the formula. You guys remember how we declare constants in Java? Double gravity 9.8. And that should do exactly the same thing as before. The only difference is that we are now coming in through constant, just a way for me to review some of the concepts we learned in the previous classes. The more we review, the more you get familiar with them. Basically, that's the point.